Hey guys, I miss you. So we learned to find a Taylor polynomial for a function, and I introduced you to the formula for the series, and I tried to emphasize and re-emphasize the fact that when c equals 0, the series is called the Maclaurin series. So for this first example, a few days ago we found a Taylor polynomial, and now we're going to find a Taylor series. Sorry about that. So we're going to generalize it with summation notation rather than finding the remainder. So we're going to find a Taylor series for f of x equals e to the 5x centered at c equals 2, and my cat has figured out how to open my screen door, so if you hear me yelling into the microphone and saying weird things, that's what's happening. Okay, there we go. I had to close it a little bit because she's ridiculous. Anyway, okay, so we're going to find a Taylor series for f of x equals e to the 5x centered at c equals 2. And we need to find the first four non-zero terms and the general term. So all I've done here so far is just find our derivatives so that we can plug it in. So we're going to go ahead and plug it in for this Taylor series for c equals 2. So first we find the value of the derivatives when c equals 2. And then we go ahead and use our handy dandy little formula at the top of the page, which we should have memorized any day now. And here we have our first 1, 2, 3, 4 non-zero terms. And now we need to figure out what our general term is. In order to do that, it's going to be easier to look at what happens when we plug the numbers in. So if you look at this carefully, you can see that you always have a 5 to the power that is associated with the same power as the exponent of your variable expression. So when we come out to the end to look at the general term, we see that it's the same as, it matches that x minus 2 thing, and that e is always to the 10th. And at the bottom, that factorial also matches with the powers of both the 5 and the x minus 2. So there we go, the first 5 zero terms and the general terms. First 4 non-zero terms. I have no idea where those words came from that I just said. So there you go. There is your first Taylor series, and you can even, if you allow yourself to think about it, you can even make it into a series. See, there you go. You've written it, or I've written it as a series, and you are also perfectly capable of doing that. I can't talk. Okay, so that was great practice. Now we're moving on to 1, 2, 3 very fundamental series that you absolutely must know. Okay, so it's not very interesting. F of 0 is 1, f prime of 0 is 1, blah, blah, blah. And then we go to find our general term, and all we really have going on there is x to the n over n factorial. And then you need to memorize that because that is a redefining of e to the x using series. And there we have the Maclaurin series for e to the x. And, what else should we talk about? The domain is all reals. And I know what I need to talk about. If you were to graph both e to the x and the series on your calculator, you would see, even if you just do 3 of those terms, you would see that they match up really closely the closer you get to 0. So if you don't really understand what's going on or are confused about how e to the x equals this long thing, go ahead and graph them on your calculator. And if you don't have a calculator, use Desmos. And if you don't have a calculator and you're taking the AP exam, I don't know what we're going to do. I think there's an online option for a calculator. Uh-oh, I didn't think about that. Okay, so f of x equals sine x and f prime of x equals cosine x, yada yada. If you look, this is skipping every other term. So this is, whoops, I didn't highlight it. This is your 0th term. This is your squared term. This is your 4th term, your to the 4th term. So we're only looking at the odd terms here. So that changes what comes out of this. Okie doke. So we have only the odd powers of x. Are the sign of our derivatives or the values of our derivatives vacillate between 1 and -1. And if you look carefully, this is something only Rebecca asked about one week, so I'm concerned that the rest of you didn't catch it. This little bit right here makes everything odd. That is why it is 2n plus 1. We're only picking out the odd terms there. Then that -1 to the nth makes your power pop back and forth. Sorry, I think I just said power. It makes your sign pop back and forth. So now we have developed the series that we need to memorize for the AP exam and for your professor next year. And once you've gotten that written down, we just need to clarify that this is true for all reals, or our domain for our x's is all reals. Here you see that the sign vacillates, the value of the derivative or the original function vacillates between 1 and -1. You also see here that you're going to be looking specifically at the even powers. For sine, you were looking specifically at the odds. So you need to create an exponent that forces that into being. And there we go. Everything is even. And we know that x can be an element, x is an element of all reals. Again. So, from there, we start manipulating things a little bit, and we can integrate these things, we can differentiate these things, we can add or subtract two series, we can multiply or divide them, and you saw a little bit of evidence of that in the homework that was due today. So what you see in this first example, or example A, is instead of the sine of x, it's actually asking for the sine of x squared. So I'm going to demonstrate how you would rewrite that by writing the sine of x in the first line and then the sine of x squared in the second line. Okay, so instead of writing x, we're going to write x squared. And I'm really painfully slow at writing and talking at the same time on this thing because it takes a lot of concentration, so hopefully this won't take up too much time, but I thought it was important that I pull you through this process as slowly as I can, and this is how I can slow myself down. So if you look, I just replaced x with x squared, which is most of the time all you need to do when you get to the problems on the AP exam. Just a minute. I'm a little bit confused. Give me a second. Oh, never mind. I was looking at the wrong place on my notes. So you've got -1 to the nth. Oops, I forgot the n there too. Y'all, you need to tell me when I make a mistake. Okay. And then we have x to the 4n plus 2 all over 2n plus 1 factorial. And then we're going to differentiate it in the next step, or find the derivative of it in the next step. So, and there we go. Now, these do simplify, but don't do it. Don't get sucked into that trap. It is a time trap. It wastes time. Do not do that. Do not even do what I did right here, which is notice that I have 3 times 2 times 1, which would cancel with the 6. It's irrelevant. They know you know what you're doing. They know you know how to multiply. You don't want to lose points for multiplying incorrectly. The only thing you want to lose points for are calculus mistakes, which we all are going to do on an AP exam when there's a lot of time pressure and a lot of pressure in general. Try not to think about that. I can't believe I brought it up. Sorry. Instead, you just want to focus on proving that you know the calculus. That should be your only focus, even on the homework. Okie dokie. Last page of this bit. We're going to find a Maclaurin series for x times the cosine of x. So we're just going to take the Maclaurin series for cosine x and multiply that entire thing times x. So there we go. We just multiply that out and we get, and there you go. Beautiful. Now we're going to run back in and we're going to integrate f of t dt from 0 to x, remembering that f of x is cosine of x, and we are integrating here an improper integral. Okay, so I assume you had to press pause quite a bit for these first 13 minutes. It is a lot of information, it is a lot of writing, and I know you can handle it. Okie dokie, moving along. Okay, this harkens back to our previous lesson. We want an error less than 1 over 1,000. And look right there. Oops. Silly thing. I don't know what it does. It does this weird thing. This weird little lasso thing when I hold the what is it called? The stylus down too long. And it always trips me out. Okay, so that particular term is smaller than 1/1000th. So we only need the first 3 terms to have an approximation that is less than 1/1000th. Okay, we can say that we can use that last term, the 1 over 5040, as the remainder, because this is an alternating series where the terms alternate signs, the terms have a limit of 0, and the terms decrease in magnitude. And in fact, the approximation over here is, sorry, it's really hard for me to talk and write at the same time. You just saw evidence of that. So what you just see there is that your error, because it's an alternating series, must be less, the absolute value of the error must be less than the absolute value of that leftover term, which is in fact less than 1/1000th. So here we go. Okay, so what you see here is your error is, I don't even know how to say that. 10, hundreds, thousands, 1,000s, 10,000s, 100,000s. 195 hundred thousandths? Holy cow. That's too many words for a number. Okay, so there was something else I was going to talk about. So we found the actual error, and you must use your calculator. I remember what I was going to talk about. Here, notice up in this step that I just highlighted with a little box. That right there, I did not change that into a decimal. That was intentional. It is easier to work with fractions than with decimals. They are also more accurate. So whenever you can, try not to use your calculator. Try to minimize your calculations. Okay. I hope I didn't skip. Nope, didn't skip a slide. Okay, now we're going to find in series form an antiderivative for sine x squared and then use it to approximate the integral from 0 to 1 of sine x squared so that the error in your approximation is less than 1/1000th without using your calculator. Okay, here are your calculations leading up to your approximation. Notice that I did put in the numbers 42 and 120. Those are because I know those numbers because I've taught math since the beginning of time. I don't actually recommend you do all that multiplication. You probably want to leave this as 7 times 3 factorial and not simplify it to 42. And you probably want to change, unless you're really good at number sense. No names mentioned. 11 times 5 factorial, I would just leave that as is. It just wastes time. You don't want to waste time. Now, there is a tricky bit in all this. I went all the way down here to this 15 times 7 factorial, and all I need, or all you need, is a number smaller than 1/1000. 1,000th, and you actually have it right in front of you with just the first two terms. So you don't need all of this, and what you have right here is your remainder, because 11 times 120 is definitely smaller than 1/1000. So your approximation does not include that term. So your approximation is 1/3 minus 1/42. You do have an alternating series because the terms are alternating in sign. They have a limit of 0 and they are decreasing in magnitude. So we can use the alternating series bound to estimate the error. And then whenever I pick up the recording again, you're going to see the actual approximation calculated out too. Also, not too. And there we go. Everything I just said and more. 1/3 minus 1/42 actually equals 1340 seconds. And the actual difference between our approximation and the actual area under that curve is 744 100,000ths. Still, that's too many words for a number. Yeah. Okay. Last bit, we're going to write the Maclaurin series for f of x equals e to the x. We're going to give the first 4 non-zero terms in the general term, and we're going to use that answer to find the limit as x approaches 0 of f of x minus 1 over 2x. All sorts of little manipulations that you're expected to do on the AP exam, assuming it's the big AP exam. I mean, if it was a normal AP exam, this is what you would be expected to do. And there are a lot of interesting things about the AP exam. The AP exam is actually calibrated against several college students who also take the AP exam, who are getting A's at places like Harvard and other institutions that are a part of the College Board. So if you get a 5 on the AP exam, is the equivalent of getting an A in college calculus. So that's what they're looking for. if you get a 3, it's the equivalent of getting a C in college calculus. 4, it's the equivalent of getting a B in college calculus, because the college kids who take the exam, who test the exam, that's the grades that they are getting. So, if you walk into the classroom next year and you choose to take Calc 1 and you get a 3 on the BC, you are going to be heads and tails above everybody else, to be totally honest. Even though it's just a C in BC, it's still, you still know more because you have, you've gone through both semesters already. So here we go. We're going to do the math here, and then I have a little tag on at the end that hopefully you noticed already on Blend. Okay, if you look carefully at this X cancels with this X. Ooh, I don't like that. I want you to be able to see what's under it. This X cancels with this X, and you're left with 1/2. This X, one of those X's cancels with that X. Oh, I did that little funny thing where I held it down too long. There, that also cancels, but we're looking at the limit as X approaches 0. So all of those other X's are going to go away, and you're left with just this 1/2. So that limit for e to the X minus 1 over 2 to the X as X approaches 0 is 1/2. And there you go. Make sure you fill out the doodle poll that was at the top of today's Blend page. And there will be another doodle poll on Wednesday. We need to decide on dates for our practice AP exam, and we also need to decide on a date for viewing Calculus the musical. We do not need to watch it as a group. I would like to watch it as a group because I miss you terribly, and I just think it would be more fun to watch it in some sort of chat room, like how they have the Netflix, what are they called? I don't remember what those Netflix things are called, where you can chat while you watch the movie. But I think that would be a really great way for us to see it, so that we have that common experience and we can talk about it afterwards. So, and yes, it's going to be cheesy. It's a musical, but get over it because life is too serious right now, and we could all use a little bit of cheesiness in our lives. So, just deal. We also need to think about what kinds of assessments you want, because I must give you 2 tests. And the idea of giving you tests completely makes me hyperventilate too. One of them will probably be the practice AP exam, but I am going to simply give you credit for doing it or not doing it, because that's too much stress to put on you to grade it any other way. Then the other assessment I'd like to do is I'd like to do the project that I usually assign. The project that I usually assign is actually a lot of fun, and all of my examples are either in my email, thank goodness a bunch of people did them digitally last year, or in my classroom. So be thinking about what you might want to do, and it just has to do with calculus. Eli and Jacob's brother did a presentation on the magic of math. Some people have done it on, what do you call it? The number E. Some people have done it on the Fibonacci sequence or the golden spiral. Just be thinking about what you might want to do. And I am sorry that this is again way too long. I hope you pressed pause when you need to, use the restroom when you needed to, and ran around the block or your house when you needed to. Y'all take care. I miss you terribly. What an awful way to end your senior year. My heart goes out to you. Please take care of yourselves and your families.